Here's the first loop. Stagnant inflammatory substances disrupt the functioning of the lymphatic channels that clean the fascia. They directly disrupt their function by reducing the contraction of the lymphangions, which are the parts of the lymphatic tube that contract to suck up the recovered interstitial fluid. The fascia's waste aspirators are therefore put out of action. The second loop, the fascia cells, the fibroblasts, whose role is to keep the fascia healthy, are transformed into myofibroblasts. These become capable of contracting with small, very powerful muscles, creating a contraction zone in the fascia. The architecture of the fascia is thus destabilized, as if the Eiffel Tower were all bent up. What's more, the myofibroblasts produce collagen in the contracted area, a very strong fiber, similar to that found in scars when you cut yourself. These numerous collagen fibers completely transform the architecture of the fascia and prevent the structures that pass through it from functioning properly. The pre-lymphatic spaces, which collect the fluid about to be sucked up by the lymphatic channels, become partially or completely closed. As a result, waste removal becomes even less effective. The third loop, the release of NGF, a nerve growth factor, leads to an increase in the number of pain nerves in the area of saturated fascia. As there are more pain nerves, pain increases. The fourth loop, inflammatory substances create an acidification of the interstitial environment. Certain cells suffer and may die, releasing even more inflammatory substances. The fifth loop, as the fascias nourish and heal the organs they surround, the intestines or the brain, for example, if inflammation stagnates, these organs will function less well, leading to the appearance of numerous health problems. The sixth loop, because the pain nerves are constantly bathed in a pool of inflammatory substances, they send pain messages to the spinal cord very frequently. Certain inflammatory substances are also transported from the fascia to the spinal cord. These two phenomena lead to the creation of chronic localized inflammation, not in the fascia, but in the spinal cord. The spinal cord and the fascia around it become new areas saturated with inflammation. This inflammation will affect the glial cells around the neurons, which will start to create even more inflammation in the spinal cord. Inflammation will also affect the neurons in the spinal cord, which will send inflammatory substances back into the fascia. In addition, the spinal cord loses its ability to produce anti-inflammatory substances, which reduces protection against inflammation. Genetic changes in the neurons of the spinal cord, under the effect of NGF, amplify the pain messages coming from the peripheral fascia, which increases the strength of the painful feeling. The autonomic nervous system triggered by stress, the sympathetic system, is overactivated, leading to the release of noradrenaline in the spinal cord and peripheral fascia. This noradrenaline constricts the arteries that carry fresh blood to the fascia and medulla, reducing their ability to replenish energy. Energy-starved cells suffer and create inflammatory substances. Noradrenaline also tightens the veins, preventing them from doing their cleansing job properly and increasing the stagnation of inflammatory substances. Noradrenaline also activates muscles, large and small, creating reflex muscle contractures and tensions in parts of the body linked to the spinal cord nerves of the affected area. These areas of muscular contracture are the points of painful tension we mentioned at the beginning. Finally, because of the upward and downward connections of the sympathetic autonomic nervous system, which connects several levels in the nerve ganglia, all these effects can spread to other levels of the spinal cord than the one linked to the peripheral fascia. An initially local problem can then spread to other parts of the body. All these physical transformations illustrate possible explanations for the cause of chronic pain, as well as the essential role of the fascial system and the nervous system in the creation and maintenance of pain.